of those invisible ingredients that quietly shapes daily life. Casings on electronics, bike tires, detergents, dyes, some medicines. Many trace back to benzene as a starting block. So how is it made? First, the modern workhorse, catalytic reforming of petroleum naphtha. Refineries take light gasoline-range hydrocarbons pushed over platinum-based catalysts at about 500 degrees C. Straight chains fold into rings, rings shed hydrogen, forming aromatics like benzene, toluene, and xylenes. Then it's separation time. Solvent extraction to pull out aromatics, followed by careful distillation to isolate benzene to tight specs. Next, steam cracking side stream. When ethane or naphtha is cracked to make ethylene, a byproduct called pyrolysis gasoline, pygas, contains aromatics. Refineries hydrogenate impurities, then extract and distill benzene. It's efficient. It piggybacks on a huge plastics process. There's also surgical chemistry, turning toluene into benzene. In hydrodealkylation, toluene plus hydrogen passes over catalysts at about 500–700 degrees C, chopping off a methyl group to make benzene and methane. Toluene disproportionation uses zeolites to reshuffle two toluene molecules into one benzene and one xylene. Tunable to demand. Historically, benzene came from coal. Coke ovens for steel making produced coal tar. Distillation pulled out benzene. It still exists, but oil-based methods dominate. Cleaner and more scalable. Why make so much? Because benzene is a gateway molecule. Turn it into styrene for polystyrene and ABS. Into cumene, then phenol and acetone for resins and adhesives. Into cyclohexane for nylon. It's the hub in a giant wheel of modern materials. But there's a catch. Benzene is hazardous. Plants use closed systems, strict monitoring, and capture technologies to minimize exposure and emissions. The goal? Keep the chemistry and benefits. Keep the molecule out of our bodies and the air. So next time you tap a keyboard or ride on rubber, you're brushing up against a long, hot journey of rings, catalysts, and careful separations, ending in a tiny molecule with an outsized impact.